Alright, I'm going to show you how to create the Ipe Block Design, which is really just an Rtl block design for the ring counter that was synthesized in myHDL. So I've got the ring counter source file located in the Vivado project along with the test bench, and the constraint file which I've set to target it. So I'm going to go create block design. I'm going to name it something meaningful, ring counter block, local to the project. Next, I'm going to go and add module after hitting right click. So this is going to create an Rtl module. It's kind of acts like an IP. The design assistance available is going to try to do run connection automation. Don't do it. Because we're using the clock. We're using a button to set the clock, and two, the seed value is going to be a constant. So we're going to do that at go to add IP, type in const. So this creates a constant bus signal. We're going to just click on there, draw all the connection. Then we're going to double click it or right click it and hit the customize selection. This is a 4-bit bus, which we can clearly see. Looking at the RTL, 3 down to 0 means 4. Then the value, we're just going to put in 3 because that's what we use in the test bench in the myHDL. Hit OK. That's going to set that. Next, we need to create the external connection ports for all these So we're just going to select, do it again. Select port, select the port, hit make external. Then we're going to need to go over here, select out that port, go over here to external port properties, name. We're going to get rid of that so it matches exactly what we have in the constraint file. Well, external. Select. Okay, now that we have all our ports set up, we're going to go to up here and hit regenerate layout, and then optimize routing. That's going to just clean up the block, which is really handy for larger designs. And then this is absolutely important. Hit validate design. Validation successful. This doesn't guarantee that it's going to synthesize or run implementation, but it definitely will check for errors. So the next thing we need to do is we need to go to sources. And as you can see, ring counter is still our top module, and this isn't even implemented as either Verilog or VHDL. So we need to right click here on the block and create Hdl Wrapper. So this is going to take everything we have in this block design and create a Verilog code that wraps the ring counter and everything we've done here into one giant Verilog file. And we're going to typically we use let auto manage the wrapper and auto update everything. So any changes we make here will automatically propagate back up to the Verilog we're going to create. Run this. It's going to take a minute to do the updating here. And so what's happened is it's because the ring counter is internal to this RTL. Now it's going to bring that as a submodule of the ring counter block, and we can see it right here. See we dig through. We can see the ring counter that we initially had. Everything else has been tied together, other than this giant and this is top level old Verilog file that then we can do the RTL, the synthesis, the implementation, generate the bit stream. So that's how we create an IP mod, a block diagram design for the ring counter, which we had to do because CE takes in a constant value, which we don't really have a good way to put that on the PYNQ-Z1, and how to actually then instantiate it within the source to actually then synthesize. Thank you.